So when you see an equation, first we're dealing with absolute value equations, but you might have also seen this using parabolas where instead of having the straight lines, it had parentheses. You might see it in fraction form where the x minus h is underneath the fraction. You guys could see it using logarithms where it'd say log of and then it would have parentheses and x minus h. So this form is going to be something that we see no matter what equation we work with. This is just the very first one. So it's going to seem weird today and then you're going to get used to it and we're going to do it all throughout Math 3. So the number in the front, if the number in the front is a negative, like -5 or -2 or -7 or -1.9, that means that the entire picture of the graph has been reflected over the x-axis. So that's if A is negative. If A is negative, it means that the entire graph has been reflected over the x-axis. If the absolute value of A is greater than 1, so it doesn't matter if it's positive or negative, it could be like 5, it could be -3, it could be 1.7, it could be -2.3. If the absolute value of A is greater than 1, it means that the graph has been stretched. So that means that a graph is now, it's like you took the graph and you stretched it vertically. So a graph would become taller and skinnier if you do that, if you like took it and stretched it out. If the absolute value of A is less than 1, it means you compress the graph. Squish is another word that people use that's not very mathematical, but means the same thing. So it means you like took the graph and like squished it between something and it makes the graph look short and fat, right? So these are different things you can do to a graph to make it look different. These are called transformations of the graph. Do you guys remember learning about transformations in like geometry? Yeah. You had like reflections and rotations and stuff like that. So we'll do the same thing. We're not quite rotating, but we are going to take the graphs and we are going to reflect them, which is what that one is. And then also we have where we can slide it to the left and right, shift it to the left and right, or shift it up and down. So this value right here is shifting it to the left or to the right, and it's the opposite of what you would think. So positive numbers actually move the graph to the left. Negative numbers move the graph to the right. And the reason it's the opposite of what you would think is because you have to think about what you would do to get this number outside of those grouping symbols. So if this was a negative value and I needed to move it outside, I would have to do the opposite. I would have to add it to get it outside, right? So these are the two that are opposite of what you would think. The number on the end tells you how far the graph goes up or down. And that's already outside the grouping symbol, so those are exactly what you would think. Multiply means you're moving the graph up, or sorry, plus means you're moving the graph up, subtract means you're moving the graph down. And again, this is something that we're going to do with every single graph all semester long, so you're going to get really familiar with these. Okay. Do you guys remember what absolute value signs do to numbers? Yeah.
It makes the number positive no matter what.
Yeah, it's always positive. So we're going to go ahead and first we're going to graph the equation y equals the absolute value of x. We're just going to graph the regular version of this first. When you look at a graph and you don't have any transformations on it, we call that the parent function. So that's like the original graph, nothing has changed about it. So some good points to plug into your parent function to see what it looks like would be x values from -2 to +2. And that's because you can see how the negatives act when you plug them in and how the positives act when you plug them in, and you kind of see a good image of everything. So what happens, what value do I get for y if I plug -2 into an absolute value sign? Get +2. What if I plug in -1? I get 1. What if I plug in 0? 0. And then if I plug in 1? 1. And then 2? 2. Okay. So now we're actually going to go ahead and graph those points. So we have the point left 2, up 2. And we have the point left 1, up 1. And we have the point 0, 0. And the point right 1, up 1. And right 2, up 2. So this graph is a perfect V shape. And if you look at the pattern, you can see that it goes over 1, up 1, over 1, up 1, over 1, up 1, and it just does that in each direction. So that's what an absolute value graph looks like if you haven't done anything to it. Just a normal absolute value graph. Are we good so far? Does that make sense? The next graph that we want to look like is what happens if you take this graph and reflect it over the x-axis. So if I take the graph and I reflect it, how is that going to change what it looks like? Yeah, flip it upside down. So the point that was on the x-axis right here, it's called the vertex. That's going to stay there. But instead of going over 1, up 1, over 1, up 1, over 1, up 1, it's going to go down. So over 1, down 1, over 1, down 1, over 1, down 1, and so on. The next one that we're going to draw is a stretch of 3. So we're going to say y equals 3 times the absolute value of x. So a stretch of 3 is not going to move the vertex. The vertex is going to stay in the same place. But it's going to make the graph 3 times as tall as it normally is. So the graph, instead of going over 1, up 1, it's going to go over 1, up 3. Over 1, up 3. Over 1, up 3. Do these little squares make your guys' eyes bug out?
Yes.
Yes, me too. I was like, I wish I had made that with a bigger grid. Okay. Do you guys see how this made the graph taller and skinnier? Okay, so stretches, just take the graph and you stretch it vertically, it makes it skinny. All right. Next, we're going to go ahead and draw a compression or a squish. So we're going to say y equals 1/2 absolute value of x. So this one is going to start at 0. And then instead of going over 1, up 1 each time, it's going to go over 1, up 1/2, over 1, up 1/2, over 1, up 1/2, over 1, up 1/2. Oh, that's hard to see. Is that better? Can you see it? So when you compress the graph, it makes it super fat looking. Squishes it. This was y equals 1/2 absolute value of x. Okay. Another type is the left or right. So we're going to say y equals the absolute value of x minus 5. And this is the weird one. This is the opposite of what you would think. So is this one going to the left or is it going to the right? It's going to the right. So here, instead of the vertex showing up at 0 like it normally does, the vertex is going to be 5 spaces to the right. But then after that, it's going to grow like it normally does. So over 1 up 1, over 1 up 1, over 1 up 1. All right, and then the last one, if we have y equals the absolute value of x, subtract 7, what would this one be doing? Going down 7. So this one isn't left or right because the number's outside. You see that? It's on the end. Okay. So instead of the vertex being at 0, we're going to count down 7. And then it's going to grow like it normally does. So over 1 up 1, over 1 up 1, over 1 up 1. Okay. What transformations do you guys see in this example? Okay, so I've got a stretch of 2. What else do we see? Right 3. And then what's the last one? Up 2. Okay. Now I'm just going to copy the table from the front page. We had -2, -1, 0, 1, 2. And the y coordinates were 2, 1, 0, 1, 2. So what we're going to do to graph these is we are going to make a chart that uses all of these points. And we're going to take the points and we're going to apply the transformations to them one at a time. Okay, so I'm going to write down these 5 points. I've got -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. When we write points down, we have to keep in mind the first one is the x-coordinate, the second one is the y-coordinate, and x's always talk about things that happen that go left and right, and y always talks about things that happen that go up and down. So when I look at the transformations and apply those transformations to my points, I'm going to start with the first transformation in the equation, and the very first one was a stretch of 2. So if I take a graph and I stretch it this way and make it taller, is that something that's going to affect the y or the x if I'm stretching it this way? That's the y, right? Because I'm stretching it up and down. So a stretch of 2 is going to change my y-coordinate. It's not going to do anything to the x-coordinate. So I'm going to just show my x-coordinates are going to stay exactly the same. And if I am taking my y-coordinate and I'm stretching it by 2, I'm making it twice as tall. What should I do to make it twice as tall? Multiply the y-coordinate by 2. So go ahead and take all of your y-coordinates and multiply them by 2. So 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. And then so I don't forget, I'm going to write that stretch 2 was the y value times 2. If you are shifting the graph to the right 3, is that going to change your x-coordinate or your y-coordinate? It's going to change your x-coordinate. So right 3 is something that happens to the x value. So that means all my y coordinates are going to stay the same this time. They're not going to change at all. If you are moving the x-coordinate to the right 3, should you like multiply it? Should you subtract it? Should you add it? We're going to add it. If you move something to the right 3, you're going to add 3. So negative 2 plus 3 is 1. Negative 1 plus 3. 0 plus 3. 3. 1 plus 3. And 2 plus 3.
Can you look at the front really quick where we just took notes like on y equals? On the right, I would say minus.
If you move, so if you look here to identify what the transformation is, you say it's a minus, and that tells me I'm moving to the right. So over here, I could see a minus in the equation. That told me I was moving to the right. But when I actually take a point and move it to the right, I add
That's why I
numbers.
was confused on why you wrote it.
No, you're right. You're right. Does that make sense how it's different, though?
Yeah.
So we've got right 3. And the way that I did that is I took the x-coordinate and I added 3 to it. Okay? My last transformation is up to, does that happen to the x-coordinate or the y-coordinate? Happens to the y-coordinate. So my x's are all going to stay the same. And how do we go up to? Add 2. So 4 plus 2 is 6. 2 plus 2 is 4. 0 plus 2 is 2. 2 plus 2 is 4. 4 plus 2 is 6. So up to was the y-coordinate plus 2. Once you get to this point, these are the points that make the graph. So now you can go ahead and draw your graph.
Wait, so basically we're just doing all of that with the points.
Yes. So the reason that we're learning this is because I want you guys to be able to see how transformations move things, like how it works. And then I also want you guys to be able to know what all the parent graphs look like. So we're not just doing it for this. We're going to do this for all sorts of different graphs so you can kind of see how they work and what numbers you can plug in and what numbers you can't plug in. So this is tedious right now, but it's going to make you guys really good at having an intuitive sense of how graphing works. And you're going to have an intuitive sense of how, like you're going to have a math, like common sense kind of with math about how numbers work and how the transformations work within the graphs. It'll make you understand things better, even if it's kind of annoying right now. So by the time we've done this for the 5th graph, you'll be able to shortcut this and do all the steps at once, basically. Okay. So right now it's tedious. It will get less tedious over time. Yes? We're going to do another one, and I'll ask the same questions, and we'll see if it makes a little bit more sense the second time, okay? So 3, 2. Yep. Now we're plotting the points. And if you look at this sketch of the graph, you can actually see all the transformations in there. So I can see that this graph, it went over 1 up 2. So that's the stretch of 2. Over 1 up 2, over 1 up 2. I can see that the vertex has moved to the right 3 from the center. Moved to the right 3. And I can see that from the center, the vertex is up 2. So all those transformations are visible in that picture. All right? Okay. We're going to go ahead and look at the next one. So what are the transformations that you guys see in the next one? We got the negative in the front. What's the negative mean? Reflect over x. Okay. What does the 1/2 mean? Compress. Yeah. Oh, that's what you're talking about. Compress by 1/2, right? And what does the plus 1 mean? Yeah, left 1. So I'm going to put my points in there. So for reflect over x, we are taking a point that is up above the x-axis, and we are moving it down below the x-axis. Is that going to be a y value change or an x value change? You're taking it from up to down. That's a y value change. So reflect over x is going to change your y coordinate. That means that all my x coordinates are going to stay the same to start with. So for this first point, the point is 2 spaces above the x-axis. So when you reflect it, where is it going to go? It's going to go down below 2 spaces, so -2. This point is 1 space above the x-axis, so where does it go? It goes to -1. 0 is on the x-axis, so when you reflect over the x-axis, does it move? No, it stays there. And we already did these ones. 1 above the x-axis is going to flip over, and it's going to be 1 below the x-axis. 2 above the x-axis is going to flip over and be below the x-axis by 2. So for this column, we did reflect over x. What happened to our y coordinates when we did that?
Multiplied by.
Yeah, we multiplied it by -1. So I'm going to say y times -1. Anytime I want to do a reflection, I just have to take the y coordinate and multiply it by -1, and that will take care of the reflection for me. Okay. Our next one is compressed by 1/2. So I take a graph that's like this and I squish it in half. Is that going to change the y value or the x value? That's going to change. I'm going like this, up and down. That's the y value. So compress by 1/2. And if you compress by 1/2, it's like you're cutting the graph in half. You're squishing it. So you could take the number and multiply it by 1/2, or you could take the number and divide it by 2. It's up to you. You can do decimals or fractions. Again, it's up to you. So whatever you're most comfortable with. So if we do this, this is the y coordinate is changing, so our left coordinates are our left and right, the x values are going to stay the same. I'll go ahead and write all those down. So if I take the -2 and I multiply it by half, what do I get? -1. If I take -1 and multiply it by half, what do I get? -0.5. If I take 0 and multiply it by half, 0. If I take -1 and multiply it by half, and then -2 multiplied by half, -1. So compress by 1/2 means I take the y value and multiply it by 1/2. Okay. Our last transformation was left 1. Does that happen to the x value or the y value? The x value. And what should we do to the x value? To move left 1. I subtract 1. Okay, so my y values are all going to stay the same. And for each of the x values, I'm just going to subtract 1. So that would be -3. That would be -2. That would be -1, 0, and 1. And now it's ready to graph.